This is a two-part question. So for the first part, we have our radius being 15 inches, and we want to know what the volume is changing by, that rate. We know the radius is changing at a constant rate. So when we're looking at what we're given here, we're given that your radius is 15. We know the derivative of your radius because you know the rate of your radius. That's your derivative of your radius is 5 inches per second. And we're looking for the dy or dv dt. So you want to start off with an equation that relates your variables. In this case, we're dealing with your radius and your volume. So you want to start off with your volume formula. Once you have your equation that relates your variables, you then need to go ahead and do your derivatives with respect to t. Left side, your derivative with respect to t. The right side is just this. Because remember, you put your 3 down in front, undoes the divide by 3, decrease your exponent by 1. Remember, times the derivative of the inside, derivative of r with respect to t. Then all we have to do is plug stuff in. And we get our answer 450 pi. In this case, it's going to be inches cubed per second. Your units are always going to be the units of what you have over here. Units of your volume over units of your time. The second part of the question states, when the volume and the radius of the sphere are changing at the same rate, what's your radius? So that means that the derivative of your volume with respect to t is equal to your derivative of your rate with respect to t. And here we're talking about the values being equal, but the units would not. So if this was 5, then this over here would be 5. And we're looking for our radius. So we're going to just start off with your derivative. I'm not going to go ahead and derive it again since we have it right over here. We know that dv dt equals dr dt, so you could basically drop those out because they're the same value on each side, so you could divide each side by them. Now you want to solve it for r by dividing by your 4 pi, then you want to take your square root. Then you'll have to go ahead and rationalize the denominator by multiplying the top and bottom by root pi. And so you get root pi over 2 pi inches for your radius. Here we have two people walking. One's walking away from the corner, one's walking towards the corner. We want to know, how is the line of sight between them changing? So if we give the person walking on the horizontal main street to be x, because that distance changes, so it's a variable. And the vertical distance here, going on Byron Avenue, is y. That distance also changes, and the distance between them changes, so you're going to have a variable for all these distances. Now, we do know a particular x and y for the instant we're looking at. But prior to our very end, we don't want to actually plug those in for x and y. Now, if you did want to figure out z in the situation where x was 400 and y was 500, you could use your Pythagorean theorem. We'll need that later. We don't need it now. But you'll notice up above here, you're looking at the person on Main Street. Their rate, their velocity is 40 feet per second. It's increasing, so it's positive. So that's the derivative of your x with respect to t. Then we also have the derivative of our y with respect to t, because we have George walking down Byron Avenue. But since his distance is decreasing, our rate is negative. And what we're trying to do here is to find our dz dt. The equation that would relate these would be our Pythagorean theorem. So, this is what it is we're trying to find, the distance between the two people. So that means we're going to have to take our derivative of the Pythagorean theorem red equation here with respect to t, derivative of x squared with respect to t, remembering the chain rule, plus the derivative of y squared with respect to t equals the derivative of your z squared with respect to t. Here you'll notice everything has a 2, so all the 2's drop, dividing everything by 2. Now we're trying to go ahead and find this. Well, at this point, all we really have to do is just go ahead and plug everything in. Your x is your 400, your dt is 40, 500 is your y, dy dt is negative 30. Your z, we just figured out with that root up there. We don't need to know the actual value. We could just leave it as this. Then you want to just continue to solve that. So you work out the left side, work out the right side, divide, you get 10 over the square root of 41 feet per second, which is approximately 1.59 or 56 feet per second. In other words, the line of sight distance between them is increasing at a rate of 1.56 feet per second.